Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over your Unit 3 solutions. Question 1, the most common frequency in the United States and Canada is 50 hertz. That's false. Remember, it's 60 hertz. Question 2, the peak-to-peak value is measured from the maximum value in the positive direction to the maximum value in the negative direction. That's true. Question 3, a transformer permits voltage to be stepped up or down. Question 4, the most common of all AC waveforms is called the sine wave. Question 5, each complete waveform of 360 degrees is called one complete cycle. Question 6, the sine wave reaches its positive peak voltage at 90 electrical degrees. Question 7, the number of complete cycles that occur in 1 second is called the frequency. Question 8, frequency is measured in units of hertz. Question 9, a sine wave has a maximum voltage or a peak voltage of 138 volts. What is the voltage after 78 degrees of rotation? So the expression instantaneous value of voltage V instantaneous is equal to the peak value of voltage V peak multiplied by the sine of theta. So I plug these numbers in. 138 multiplied by the sine of 78 degrees gives us about 134.9 volts. Question 10, the root mean squared or RMS value is also called the effective value of voltage. Question 11, if the period of a square wave is 22 milliseconds, what is its frequency? Remember, time and frequency are inversely related, so I take 1 divided by 22 milliseconds, always convert to base units, and I'll get a frequency of 45.4 hertz. Question 12, we have a 20 volt AC voltage source in a series circuit with 2 resistors in series. R1 is 4.7K and R2 is 1.5K. It's asking us to calculate the voltage drop across R1. We can do this a couple ways, so I did it all in one step using voltage divider. So VR1 is going to be equal to R1 divided by R1 plus R2 multiplied by the source voltage. So I plug those values in. Voltage drop across R1, VR1 should be 15.18 volts. Question 13, same circuit. Now it's asking us to calculate the power dissipated, PR1. So I have to solve for the current in the circuit first. I is equal to the source voltage divided by R equivalent. So 20 volts is the source voltage, R equivalent. I take the 2 resistors, add them together. Series circuit, 4700 plus 1500. I get a current of 0.00323. Now to calculate the power dissipated, PR1 is going to be equal to VR1 multiplied by the current. So 15.18 multiplied by 0.00323 gives us a power of 0.0489 watts. Question 14, resistive loads produce heat. That's true. Question 15, when magnetic lines of flux cut through a coil, a voltage is induced in the coil. That's true. Question 16, the schematic symbol used to represent an inductor depicts a coil of wire. That's true. Question 17, an induced voltage is always opposite in polarity to the applied voltage. Question 18, how much voltage is necessary to push 0.8 amps of current through a 6 ohm value of resistance? Very simple Ohm's law, V is equal to I times R. Plug the numbers in, current is 0.8 amps, resistance is 6, so the voltage will be 4.8 volts. Question 19, inductive reactance is proportional to the number of turns of wire. Question 20, an inductor has an inductance of 0.8 henries and is connected to a 120 volt 60 hertz line. How much current will flow in the circuit if the wire of the resistance of the inductor is considered to be negligible? Well, what we're going to do here, Ohm's law again, I is equal to V divided by this time X sub L, and X sub L is the value of inductive reactance. So remember, X sub L is equal to 2 pi multiplied by the frequency multiplied by the value of the inductor. So I plug these values in, 120 divided by 2 pi multiplied by 60 multiplied by 0.8, and I'm going to get a current of 0.398 amps. Question 28, VARS is an abbreviation for volt amperes reactive. Question 22, polarized capacitors can be used in AC circuits only. That's false. Question 23. Capacitors contain insulating materials known as a dielectric. Question 24. Basic unit of capacitance is the farad. And the last question, question 25. A dielectric test is often referred to as a high pot test, where high pot stands for high potential. Thank you.